How about critical points? This is a topic which is quite critical. No, just kidding. Critical points is, I would say, very, very, very easy, but I know, and a lot of my friends, when we had this topic in class, had a lot of problems, and they said, oh my god, critical points, how to calculate that? And maybe they could understand it in the first class, but second class they already forgot it, and they couldn't calculate it anymore. Or they had problems with their homework, or they could calculate it when we had it in class, when our teacher explained it to us, but later in the exam or in the A-level exam, they had a lot of trouble, and they forgot it. Oh my god, critical points. This is all rubbish. It's very easy. Critical points, you have just to know two things, right? Two things. Look into my eyes. Two things you have to know, and I also write them down for you. The first thing, critical points. The first derivation has to equal 0. It's always the same, right? The second point is the second derivation does not equal 0. When it equals 0, you have to do some further analysis with limit. You have to look at your point, because the first condition is always the necessary condition, it's not a sufficient condition, right? First condition, as I said, first derivation is 0. The second condition is, as I said, the second derivation is not 0, does not equal 0. So in this case, you have to do analysis with the limit. You have to go to the left of the point, you have to go to the right of the point, or you say, okay, I have x, and with x I go towards this critical point, and then I see which result I have and what comes out. And also to the left, of course, from the right you go to the point, from the left you go to the point, and in both cases, if you end up with the same result, that you go towards minimum, you will realize that when you do the limit, then of course you can say it's minimum. You also have to pay attention. Some functions may have, maybe I can show you an example. If you have a function, and this is possible, it depends on your teacher, it depends on your professor, whether they want to give you difficult exercises or easy exercises, but it could be, this is a nice exercise. You see, it's a function actually. In this case, you see there is one point which is down here. The function is not defined in this one point. And this is possible that you get this exercise and you have to say, okay, is there a minimum or not? In this case, you can say actually here's the minimum and here's the minimum, and this is a little bit more tricky. But usually, I mean, this is quite advanced, and you need to practice this, of course, a lot. But basically, the principle is always the same. As I said, first condition, the first derivation equals 0. The second condition, then the sufficient condition is the second derivation does not equal 0. So in case it equals 0, it doesn't mean that there is not a minimum or a maximum, but it can be, there is maybe a minimum, maybe a maximum, or there's something else. This is also possible, since the first derivation will be 0, but the second derivation, in this case it might also be 0. So something like this. And this is what you have to check out. In case your second derivation really equals 0. When it does not equal 0, then it's easy. Then you can say when it is greater than 0, then you know it's in this at this position you have a minimum. When it is smaller than 0, then you know it has to be a maximum. So I just wrote it down for you again. This is all you have to know about critical points, right? So first derivation is set 0. That's what you calculate first. This is the necessary condition. Second, second condition, the sufficient condition, is the second derivation is not when it does not equal 0. You can easily say, okay, when it is bigger than 0, then it has to be minimum. When it is smaller than 0, then it has to be maximum. And in case it equals 0, you have to do some further analysis. You have to work with limit, or it does also depend actually on the curve behavior, what it does and what you think it does, and whether it has some exception. As I said earlier, when it does things like this, it depends. I would say that you cannot talk about a general procedure in this case, but you have to do further analysis. And the thing I would start is maybe just imagine what the function would most probably look like. If you have a calculator which can do that, then you can also use it, of course, and have a look. And then you can decide what you do next. And in most cases, I would say do some analysis with limit, and you say, okay, I come from the right, I come from left. and I have looked whether the function is defined in this point, and then I can say, okay, most probably there is a minimum or maximum or something going on, right? So not too difficult. What you should keep in mind is these two steps. So you have the necessary condition and the sufficient condition. By this you can find out about critical points. And this is always the procedure. It does not change. It's always the procedure. Also when you go maybe into economics or innovation theory and you want to do some nice proofs, it's always the same, right? First condition, first duration equals 0. This is how you start. And don't forget about the second one. Second condition is the sufficient condition. The second derivation does not equal 0. Then you know either maximum or you know either minimum. Or if the function does some special things, then you have to do some analysis with limit to find out what it does. Okay, so this is how it works. And I'm going to show you again on more paper how it works in the following clip. How to find critical points of a function. Critical or extreme points. It's actually quite easy. There's a procedure, and the procedure is always the same, whether you're on high school or on college. The procedure is always the same, and I just introduced it to you. Procedure consists of two conditions. The first condition, also called the necessary condition or necessary constraint, is called or says first derivative is set 0. The second, the sufficient constraint, sufficient condition for a critical point is the second derivative does not equal 0. If it is greater than 0, we can say we have a minimum. If it is smaller than 0, we can say we have a maximum. It's that short. That is everything you need to find critical points of a function. It's always the same, and you should know this maybe in the beginning. If you didn't understand it 100%, you should know this by heart for sure. But it helps a lot, actually, also to remember in the exam. Maybe you have a lot of stress during the exam, and if you understood how it works, these two steps, then you're fine. Then you don't need to learn it by heart. But first, it may help to learn it by heart. So, how does it work? For example, if you... Okay, first thing you have to remember. For example, very simple function may look like this. So, we have a minimum we can see, and critical point, where is it? Of course it is where the slope is negative before negative, 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 all the way. But it becomes less negative, right? Less negative, less negative, less negative, and here the slope is 0 suddenly. Then it is positive. So we see slope is negative right before, slope is positive right after 0. And in between, of course, if we have something negative first, like this is 0, minus 1, plus 1. If we have something negative, 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 how do we get to positive? Of course, we have to somehow to pass through 0. And how are we going to do this? Of course, 0. We see the slope has to be 0 in between negative slope and positive slope. So slope is 0. The first derivative gives us information about the slope of the function. So we see in this point, there, the slope has to be 0. And this is the necessary condition to find a critical point. The second one. Why do we need a second one? Because it could also be, for example, consider this function, the same function, just negative and moved a little bit. Here the same thing. We have positive slope. Here we have negative slope. So from positive to negative, if we move, of course, we will pass 0. And 0 is where the maximum is. So in this point also we have first derivative is 0. So we see that the first condition is not sufficient, right? It could be both, like minimum, maximum. Actually there's a third thing which would be possible, which may look like this. So in this case, here we see positive slope, and then afterwards still positive slope, but in between we have 0, like we come from right slope to less, 0, and then becomes more. We don't go into the negative area. So it could also be something like this. So with the necessary condition, we don't know actually a lot. We know there may be some critical point, maybe, but we don't know for sure, and we don't know for sure whether it's a maximum or a minimum. So that's why we need our second condition, the sufficient condition. So we calculate for this, we can calculate the first derivative, consider this as a function, then as I said, this may be like this may be the function, the functional term, and if we take the derivative, if we differentiate it, what will we receive? Obviously we will receive like 2x. So we have like 0, we know for sure this goes through 0 because the slope is 0. Before it is negative, afterwards positive, and we have 2x, so it will be a little bit steeper than x. 2x, so it looks something like this. First derivative. Second. Second tells us whether it's maximum, minimum, and we see if we differentiate 2x, we will receive 2 very quickly. And we also see it, of course, the slope is always the same. In every point, the slope is the same. The slope is 2, right? So we see here positive. 2 is positive. So we see for a minimum, the second derivative, if it's positive, if it's greater 0, shows us that in the function at this x coordinate we have a minimum, right? And it's the same if I would do it like for this function. We would also see that if the value we receive, then we see in the second derivative is smaller than 0, then we have a maximum. Right, so this is the theory, but still, if you have a little bit problems to understand all this, you can focus on this bubble. You just learn by heart first and second constraint, first and second condition, the necessary conditions, and the necessary condition and the sufficient condition, which tells us whether it's a minimum or a maximum. So let's just try it out with a short example. So let's have a function which looks like the following. So we have f, which looks like this. This is f, so this is a 2. Yeah, sorry for my handwriting. This is a 2. And first, before we begin, we can, because we already know we need first derivative, second derivative. So we just get it, and what does it look like? 4 times 4 is 16, and 8 times 2 is also 16. Second derivative does look like 16 times 3 is 48, and again here we have 16. So we have the first 2 derivatives. That's all we need to solve this case. And so we start with the necessary condition, which says again like first derivative is set 0. So that's what we are going to do. We have it already. So you just set it 0. So now what can we do? We can divide by 16. That's not going to happen bad stuff.
when we do this. And we can maybe write it a little bit different, so it looks like this, right? And then we can say, okay, first we can say this equation solved when we say x1 equals 0. That works. And we can continue and say, okay, maybe continue with this part, and then we can say something like this, okay, and solve it. Then, okay, we see this is going to be a complex number, but complex number, okay, depends on whether you have it in your class or not. But at this point we say, okay, we don't calculate with it, we say, okay, this is a dead end. So we don't use this solution, but we already found a solution, which is x1 equals 0. Okay, now we know it has to be most probably a critical point. Could also be something like this, right? We're not sure yet, but we can now calculate the sufficient condition, which is the second derivative does not equal 0 to be a maximum or a minimum. So we just say we have 0, x1 equals 0. Just put it into the second derivative, and then we receive 48 times 0 squared plus 16. Obviously 16 greater than 0. And if you remember, greater than 0, what does it mean? This. So it is, we see a minimum. It's that easy. So we just write minimum. Then we're done. So it's really not that difficult to calculate. You just have to remember how it works. Two conditions: necessary condition, sufficient condition, and there you have it. Thanks for watching.
Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.